everybody, Mrs. Pesic here. We're looking at Chapter 7, Similarity, and today's lesson is 7.1, Ratios in Similar Polygons. Your goal is to identify and apply properties of similar polygons to solve problems. So what does similar mean? Similar means that the shapes, that the figures that you're looking at will have the same shape, but not necessarily the same size. So for example, in our pictures here, it looks like triangles 1 and 2 are maybe similar to each other here, but 1 and 3 are not similar to each other. All right, what's a symbol for similarity? We use this symbol to indicate similarity. You know, we use this symbol to indicate something is congruent to something else. But without the equals part, we leave that part off, and we just use this symbol here to say is similar to. So that's what that symbol means when you see it. Okay, so similar polygons are going to have corresponding angles that are always congruent, and corresponding side lengths are not going to be congruent, but they will be proportional. All right, so we see here in this figure, we've got quadrilateral ABCD, and we've got quadrilateral EFGH. And notice we have a similarity statement here, which is telling us that these two quadrilaterals are similar, but not only that, angle A must match up with angle E, and that means those have to be congruent. So angle A is congruent to angle E. Same thing with angle B and angle F. They have to be congruent. Angle B is congruent to angle F. Same thing with angle C and angle G. They have to be congruent. And lastly, D and H have to be congruent. That's what you say is congruent to. Angle D is congruent to angle H. So the angles do have to be congruent, and we can see that in the picture. We see that angle A and angle E are both right angles, so it makes sense that they're congruent. And we see that D and H match up because they are both right angles as well, so that takes care of this one, and that takes care of this one. And then angle B has got one tick mark right here, and angle F has one tick mark right here, so we see that they are congruent as well. And lastly, we see that angle C has two tick marks and angle G has two tick marks, so that means that they are congruent as well. So all of our matched up angle pairs are congruent. But don't forget the other part of similar polygons is that the corresponding sides have to be not congruent but proportional. So let's check that. For corresponding sides, that we can also get from our similarity statement. In this case, I see that AB is the first two letters and EF are the first two letters. So that means that AB must line up with EF. And the ratio of side AB to EF, in this case, here's AB is 6 and EF is 12. So we see that 6 is to 12, but that means that has to hold for all of the other pairs as well. So I can slide this over and say, what about segment BC and FG? What's the ratio of BC to FG? Let's check in our picture. BC is this segment, and that's 5.4. And FG is this segment, and that's 10.8. Well, I see up here that 6 over 12, that reduces to 1 over 2. And 5.4 over 10.8 also reduces to 1 over 2. And does that hold for the other sides as well? Well, here I have DC and HG. If I look at those ratios, DC is to HG. That is 4 is to 8. That also reduces to 1 to 2. And what about my last angle pair? That would be AD. I'll squeeze that in up here. AD should be proportional to EH. That's supposed to be a D. AD is to EH, and that is 5 over 10. So again, all of these are reducing to the same fraction of 1/2, so that means that the sides are proportional. So the angles are congruent and all the sides are proportional. So yes, the two quadrilaterals are similar. So the similarity ratio is the ratio of the lengths of the corresponding sides of the two similar polygons. Similarity ratio, the ratio of the lengths of the corresponding sides of two similar polygons. So if I go back to this picture for a minute, our similarity ratio here, I can write this down, the similarity ratio for these two quadrilaterals is going to be 1 to 2. Right? We're getting that because of the fraction that each of the pairs of sides reduce to. 1 is to 2. So that's a similarity ratio. A similarity statement is a statement that indicates that two polygons are similar by listing the vertices in the order of correspondence. So we already talked about a similarity statement, and we said that this here was a similarity statement right here. That's what we mean by a similarity statement. All right, so let's take a look at this example. In this example, you are going to identify the pairs of congruent angles and the pairs of corresponding sides. Then write a similarity statement. All right, so remember that writing a similarity statement is like writing a congruent statement, so be sure to list the corresponding vertices in the same order for each. Okay, so I would say to write to identify if pairs of angles are congruent, I see one tick mark here on the R and one tick mark here on the Z. So those two angles are congruent. So angle R is congruent to angle Z. I see two tick marks on the Q and two tick marks on the Y. So that means angle Q must be congruent to angle Y. And we don't see any tick marks on S and X, but I think that we can safely say that those angles are going to be congruent because of the third angles theorem. So angle S is going to be congruent to angle X. All right, if we know those corresponding angles are congruent, that's great, but we also need to see that the corresponding sides are proportional. So if we look at the side that's running from, let's say from our one tick mark to our two tick marks here, that's QR in this case, and that would be corresponding to this segment, which is running from one tick mark at Z to two tick marks on Y. So is that proportional? Is QR over ZY equal to the same thing as, let's say this one that's running between the two tick marks and the three tick marks, that's SQ, and this one that's running between two tick marks and three tick marks, that's XY, and is that going to be the same ratio as the one that's running from the three tick marks back to the one tick mark? So that would be SR and XZ. Let's see if these proportions are really equal so that we can verify if these two triangles are similar. All right, so let's fill in the lengths and see if we get the same fraction for each one. QR here is 18, right, so that's what I'm writing here, over ZY is 12. So I get 18 over 12. And if I look at what that reduces to 3 over 2. You could do that on your calculator. What about SQ? SQ is this segment here, that's 9. And XY is this segment here, that's 6. So I get 9 is to 6. What does that reduce to? Well, that reduces to 3 over 2 also. So far, so good. And now we need to try SR, that's this segment, and XZ, that's this segment. So that would be 13.5 divided by 9. And so you grab your calculator 13.5 divided by 9, what does that fraction equal? Sure, it looks like it equals 1.5, which is the same fraction as 3 over 2. So all the sides are proportional, all the angles are congruent, which means yes, these two triangles are similar, and our similarity statement would be, we can write them in this order here. I know that I'm going to say triangle, and I can just use these letters in that order right here. Triangle RQS is going to be similar. Remember, I'm not going to write the congruent symbol. Is going to be similar to triangle. Whoops, I didn't want to drag that along. It's going to be similar to triangle ZYX. So this will be our similarity statement here. These guys don't want to split up. All right, so this should be our answer for our similarity statement. Let's take a look at this example. It says determine whether the polygons are similar. If so, write the similarity ratio and a similarity statement. Well, we already see that we have, side here. This side has length 10, and this side has length 5. This side has length 10. This side has length 5. So it's looking promising, but we should probably look to make sure that all the angles are going to be congruent. So this angle here is 36, and it's an isosceles triangle, which by the isosceles triangle theorem means that these two angles here are going to have to be congruent. And the three angles of the triangle add up to 180, so if I call this one x and this one x, I really get 2x plus 36 has to equal 180. And if I subtract 36 from both sides, I get 2x equals 144, and then dividing both sides by 2, I get x equals 72. So that means that, it's out of there, that means that this angle is 72 degrees and this angle is 72 degrees. But over here in this triangle, this side is congruent to this side. They're both equal to 5, which means that this angle here has to be congruent to this angle. So that means that this angle has to be 62 and this angle is 62. Well, that's a problem because these angles were 72, so the angles are not congruent, and we could actually find this top angle, angle T, as well. Let's see, I'll call that y. So y plus 62 plus 62 has to equal 180. And so if I'm moving over here, so that's y plus 124 equals 180. And if I subtract the 124 from both sides, I get y equals 56. So though angles are not congruent, 36 is not congruent to 56, 62 is not congruent to 72, and so on. So there is no similarity ratio. There is no similarity statement. These triangles are not similar. So I'm going to write triangles not similar because angles, I'll say corresponding angles, are not congruent. Let's take a look at this example. Determine if the polygons are similar. If so, write the similarity ratio and the similarity statement. So in this case, it's not indicated, but it should be. Let's assume that these are rectangles, and so all of these angles are right angles, right? So right now we're already covered with all the angles, corresponding angles are going to be congruent because they're all right angles. Okay, but what about the side lengths? Is PS to TW, is that ratio, we're assuming that this is going to be the corresponding side with this, but we're trying to see if they're congruent, is that ratio going to be equal to PQ and TU? Well, let's check. PS is this segment here, that's 4, and TW is this segment here, that's 6. So I get 4 over 6, and is that equal to, let's see, I've got PQ is 12 and TU is 18. So is that equal to 12 over 18? You could cross multiply if you want, or reduce each fraction. If I cross multiply, do I get the same thing? I hopefully do. 4 times 18, is that equal to 6 times 12? So if you look at your calculator, 4 times 18 turns out to be 72, and 6 times 12 is also equal to 72. So that works. If we actually did reduce these, though, we can get our similarity ratio. Both of these reduce. 4 over 6 reduces to 2/3. 12 over 18 reduces to 2 over 3. All right, so our similarity ratio is 2 to 3. That's how we would write that. And our similarity statement is going to be, I'm going to write it down here, is going to be PQRS is similar to, remember no equal sign underneath that because we're not talking about congruence, is similar to, and let's get the order of the letters the same. I started with P over here, so let's start with T over here, T, U, V, W. All right, so that is our similarity statement for this. Let's take a look at one last problem. Find the length of the model to the nearest tenth of a centimeter. The rectangular model of the race car is similar to the actual rectangular racing car. So the corresponding sides will be proportional. So in this particular problem, you're told that the model is definitely similar to the racing car. So we're not trying to verify that they're similar. We're told that they're similar, but that means you're trying to find the length of the model. We're trying to find this length from here to here, and we're calling that X. All right, so let's set up our statement. We could say that the width of the model is to the width of the actual car, and that should be equal to the length of the model divided by the length of the actual car. All right, so let's do this. Let's fill in what we know. We know that the width of the model is 6.3 centimeters, and the length of the model is 1.8 meters. So I can write centimeters here and meters here. That's okay. It's not a problem. And then the length of the model is X centimeters. We don't know what X should be. And then the length of the actual car is 5 meters. So to solve for X, we are going to cross multiply. So we're going to get 6.3 times 5 equals 1.8 times X. All right, and when we divide both sides by 1.8, you can do this math on your calculator, but it turns out to be 17.5 centimeters. Check me on that. But it's going to be centimeters because that's the units that we were looking for here, right? X centimeters. So it's going to be 17.5 centimeters. So we found the length of the model. All right, that concludes this lesson. Thanks for watching.